A lot of kinematics has to do with position versus time and velocity versus time. But here's a different kind of question, which is important. Suppose a car is accelerating. Suppose that it passes you while it's going at some initial speed, v naught, and I want to know how far it's going to travel. In other words, what's the delta x value until it's going to reach some other speed, call it v. So this type of problem is not velocity versus time, it's velocity versus x. So let's see how we do it. I'm looking to find delta x. To find delta x, we can take the average of the velocity multiplied by the time. So I have to take v average times t. So I have to make two substitutions. I need to plug in an expression for v average. Also, I want to eliminate time because I don't want to have to figure out the time it takes to get to a certain speed. I want to know just how far it goes. Okay, so first, its speed, it's just a uniform acceleration. So its speed is going from v naught to v. The average value is 1/2 v plus v naught. That's true under uniform acceleration. The velocity is just ramping up to some final value. The average is just halfway between. I have to multiply by the time it'll take the car to reach that new speed. It's accelerating, so I can find the time by just taking delta v, v minus v naught, and dividing it by the acceleration. So there I've subbed in for the average velocity and the time it takes to reach that final velocity. The expression simplifies down. I get 1/2a times v squared minus v naught squared. So by directly plugging in the starting speed and the final speed, I can predict the displacement that the car will go until its speed changes by that amount. This kind of v squared expression might remind us of energy conservation, and it is closely related to it, as we'll see later on. Now, here's a related type of question, which comes up whenever you use GPS navigation. You look at the SIG alerts and so on to figure out what route to take. How does the app know how long it'll take to cross a given traffic zone? Well, you see, we're trying to find the time. The time it takes to cross a given delta x. Like I want to go from, like here to here, and I want to know how long that's going to take to do it, given that there's slowdowns in the traffic in between. Now, time would be displacement divided by velocity. However, that's not going to work because the velocity is changing from point to point. But we're on the right track. Instead of trying to find the full time it takes to cross the whole thing, what I can do is split it up into little bitty infinitesimal time intervals, find the little bit of time it takes to cross each little bitty distance. That I can do because each little tiny interval has a well-defined speed on it. I just have to know what the speed is at each position along the route. So I take the little distances and divide by the velocities on those little intervals, and that will let me find the time across each one. I then have to add up all those little time intervals to get the total amount of time. So I can find the total travel time, t. I can't just take x over v. I have to do an integration from the starting position, x naught, to the final position. The integral that I have to do is dx over v, where I have to remember that v is a function of x. Like where it's red, the speed is only 10 miles per hour. Where it's green, it's 60 miles per hour. That's how you compute the time it takes to cross a given region. You have to know what the speed is as a function of x. So again, this falls under the category of problems v versus x. Also, crucial to note here that um, this works even if it's not a constant acceleration. Across this traffic zone here, it's speeding up and it's slowing down, and I don't know what the acceleration is. As long as I know how the speed changes with position, though, I can figure out the time, and that's how the apps work it out.